Okay, so we've just got back from Morley. As you saw on site, we've got the controller here attached to the total station. So we've got all the information on this now. We're going to load it in the computer and then we can show you what we're going to do with the Magicon here to convert that to a 3D CAD drawing. What we've done is, on screen here, I've got all the captured points that we did when you saw us on site. The easiest way to work with this now is to download it onto a software that we use called Cubular Cubed. So what basically we're going to do, we're going to create a 3D model and we're going to use that then to create a cut and fill chart showing us how many tons of material we're going to have to dig out on that site. So in this little box here, with the controller that you saw me with the total station, it's recorded all the points. I will save that now to a USB stick, basically in a CSV format. You can see on the screen here, it's just recorded as numbers and north and east positions and elevation. And then I can load that into the software that we're going to use. I use it purely for volume calculations for cut and fill. It's a free software to download as a demo version, but you can actually store some of the points in it and you can save what you're doing, which you can't do with a lot of free demo versions. There we go. We've got all the points there imported on the screen now, and purely it's just showing elevations. I know it's in the right geometry now because we had a 0 as a single line through here. This was where the existing silage pit and buildings are in this area here. So what we need to do now is just outline that and wrap it basically into that feature. Click OK, and there we go. It's created as a 3D model of the site, colour shaded. So this was the higher ground we were walking on. This was the fence line across here and round the corner of the building and the silage pit. So what we're going to do now is we're going to create the proposed cut site. So that's existing elevations. So if we go into proposed, what we end up doing then is drag a line roughly where the proposed dig off area is, which is roughly that area there, and that creates us the cut area. What we need to do here now is, because it's got us a level of 5.2 meters, we actually need that at minus 0.2, which is this bottom corner here, which would make it level with the existing concrete. And then the second thing we need to do is we need to cut we need to level an offset. So we've got an offset going from this corner of roughly, like I say, 1.8 meters from left to right. We can view that in 3D, so we can rotate round. We can see the cutout area. This is all the material we've got to excavate. It shows us the batters here we've got to put in on the sides. We've currently got that set at 1:1, so for every 1 meter up, we go 1 meter across. We can go back, we can alter the boundary if we don't think it's sufficient, and just click OK. So this is the bit on this side here that interests me now, the volumes. The volumes are cut and fill. We will have no fill because it's all digging into the existing ground, so there would be no fill to add to it. So that box remains blank. But we're looking at approximately 13,911 cubic meters of material to remove from that site. I know that this site here is a predominantly mix of stone and clay, and I think we would be looking at nearer 2 tons per cubic meter, so 26,000 tons of material to move. So I hope Lee's in for some big days, because that's going to take, I think, approximately 3 weeks to move. This exercise is purely for the customer to give him a rough idea of how much it's going to cost. So we know we've got this 26,000 tons of material to move. We know roughly how much we can move a day, and we'll just do a day rate calculation for him at what we think it's going to cost to move it.
Daily use calculations.
Okay, so we are back on the big site. You have just seen how I won the competition over the tonnage that we have to move on the job by Bridge North, which is great, I always win. And you've also seen or had another look at what Dave's total station and that package or that computer package can do. I want to show you something different now. The other system that Dave works with is called GPS. Now, I don't understand the total station, let alone the GPS. I'm not even going to begin to try and explain that to you. But basically, the reason that we're using the GPS is we're on the offsetting land at the minute, and we've got quite an oddball shape parcel of land. And as I've said in the past, we are splitting this land up into parcels that we can graze with the cattle, parcels that are set to be enriched for an ecology perspective. We need wildlife corridors to connect everything together, and then areas that we're going to leave alone because they're already fantastic. So what we need to do now is we need to map all of that, send that off to our planning consultants, Ben Wharf. Ben and the guys over there will take that data, they will work with the ecologists, they will come up with a scheme that works with all these enriched areas that are connected by corridors, and then send that back to us, and then we know exactly then what we're parcelling off, where we're doing the fencing, where we're putting the corridors. For argument's sake, if there's areas where we want to get from this higher ground, which is the old railway line, to that lower lying field, we can put a gateway in there. There's a drainage ditch along here, so we need the pipe in to take the water. Then we would also need a second pipe for any wildlife, so that might be half full of water and half open, so your wildlife can pass through, and the lower level pipe, which is just for drainage, will take the water. So Dave needs to map all this out. Now, as I understand the difference between the total station and the GPS, it's mainly down to the total station needing a line of sight. Now, with this being an odd shaped parcel of land, and we've got lots of things in the way, so we've got hawthorn bushes, we've got brambles and weeds, we've got trees, we've got woodland, we've got an entire hawthorn sort of planted area across there that we want to get all that data from. The total station would only do what you can see, and then you would have to keep moving it from place to place to place. So the GPS is far quicker because it doesn't need that line of sight. So Dave will explain more, but as I understand it, we've basically got a tripod which is on the balcony of the office presently, plugged into the electric socket and hooked up to the Wi-Fi of the office. So that creates a base point. Dave has got a tripod with a thing on the top of it. That's the second point, and the third point is Bob sat in the sky in his satellite. Now, it creates this sort of love triangle between the office block, between Big Dave and Bob, and them 3 points, and it triangulates exactly where Dave is. I don't know how accurate it is, Dave will tell you. The only thing I do know is the weather is probably the only thing that can cause any issues with exactly pinpointing that of where you are. Now, Dave will explain more of why the weather can affect that, but I've come up with my own conclusion, and I think a day like today is probably not too bad, but if the sun starts breaking through the clouds, I think what will happen is, if you imagine Dave is walking around with his staff and he's got this thing on the top that Bob's trying to look at through his telescope to see where he is, if the sun is shining in the wrong direction, there's going to be that reflection of light from Dave's head that is going to block that line of sight to the staff that he's got in his hand. So that might cause some issues and therefore make him slightly out on how it triangulates and does the measuring. But like I say, you can go over to Dave in a minute and Dave will explain more about that. But basically, that's the data that we need. This is the last piece of the puzzle, and once we've got this over and got all that information, we can finalise and get all of this on with, submit all the paperwork to the council, everybody's happy, and carry on with what we're doing. So I will leave you guys now with Dave. I'm going to go back over to the big site, as in the development side, because we're starting to put the road in. So Dave's marked all that out, put all the levels in. The guys have just started digging off the topsoil. So I'm going to go and see how they're getting on, and we'll probably bring you a bit of that side of things and the road construction in the next video. So if you like what you've seen, hit subscribe, ring the bell, and we'll catch you next time. Cheers.
Hello, Clayton. You all right?
Yeah, are you?
Not too bad, thank you.
What are you up to?
We're doing a GPS topographical survey today on this plot of land that Lee's talked about in the past, the biodiversity net gain land. So I'm preparing a survey for the planners. so that we can draw up the areas that we're going to plant up. We can get an acreage measurement off and we'll put this back into CAD. But we're using the GPS today. Lee's already explained a little bit about it. Basically, satellites, we're using satellites to this receiver on the top here, but we've also got the base station set up on the offices. We're just using it as a standalone base station, collecting data continually, and then that's sending a signal through the Wi-Fi to my phone, and then I'm taking recording data on my phone. I'm also recording some data on this data logger as well. Sometimes it's just easier to put in more detail on the data logger than just the phone only. Okay, so those are the points we recorded already. The R is where the rover, that's what this is called, the rover is positioned. It's as simple as hit measure, and then it needs a certain amount of time just to correlate all the satellites. We're currently tracking 27 satellites at the moment by the look of it. This is far quicker than the total station. We've literally done 23 points here now in probably 20 minutes. We're doing a point a minute. It's purely just stop, stand, press measure, and then move on to the next one. Okay, so here's one of the bigger issues that we have with GPS. We've lost the fixed solution. Basically the tree cover is stopping the signal travelling up to the satellite. We've got a float solution, so it means that we've gone from being 12 to 14 mil, we're now up to 100 mil. It thinks it's within 100 mil of where it should be, so I wouldn't really record that point, it wouldn't be good enough. If I wanted to record this tree, I'd have to do an offset solution, so I'd measure the distance out until I got a fix, and then I'd just plot it on CAD then and say that the solution I took was 4 meters away from the center of the tree. The weather also, I think Lee's mentioned the weather. You can have the solution from float to fix will drop out if the cloud cover gets too much, and also if there isn't enough satellites. Currently we're tracking 25, we were tracking 27 up there. If that drops down to too few satellites, there isn't enough of them to get a good enough signal, and it'll drop to float then. In the UK we very rarely have that problem. We've got plenty of satellites. We're tracking lots of different systems here, GPS, Beidou, GLONASS, they're all different constellations of satellites, so it's got more than enough solutions in the UK. But yeah, we'd need to step out from under the tree. Right, I'm going to walk off now down the railway line. You've probably seen this in a few of Lee's other videos. This is where the cattle have been grazing through the summer. I want to take a topo of both sides of the disused railway line. We can plant this up now as part of the biodiversity. And also we've got a strip of an old hedgerow line across there as well. I'm going to plot that, so I'll probably be a couple of hours walking over the whole of this 28, 29 acres, something like that, and then we'll go back to do the office and get it onto the CAD.